A container allows the developer to package the application along with the dependencies associated with it and put all in a box, which is an isolated environment, so that the underlying host, the operating system, is completely abstracted from the application running inside the box. The main problem this container technology solves is dependency issues. What is this dependency issues? It's like I build my application and it works perfectly fine in my test environment. But when it's deployed in production, a lot of issues pop up. As a production environment has a different configurations or the versions of softwares which the application depends on. And it takes hell of time to actually understand these issues and solve them one at a time. In addition to solving this main problem, there are many other benefits of this technology. This made this technology really popular. Google, for example, deploys more than 1 billion containers across its services over a week. In this video, we shall discuss about few key benefits of Docker, such as portability, density, scalability, and security aspects. If you have been to Netherlands, you'd have noticed a container restaurants. It's like you have all the stuff you need to cook the awesome recipes and serve your customers are packed into a single container. And this container can be moved relatively much easier to another place, and you are all set and ready to provide your customer with the exact same recipes and experience. Docker is a kind of similar idea, where you're packing IT application with all the libraries and dependencies in one virtual container, and which is highly portable and runs exactly the same wherever it is deployed. This portability is one of the Docker's greatest benefits. Density is another important benefit. We are dealing with isolated containers. That means that we can put more containers in one machine, which enable us to use resources more efficiently. Let's take an example. If I have a machine of 32 GB and I would like to run 3 virtual machines in parallel, I need to divide my memory among these virtual machines. For example, virtual machines, I give 16 GB, maybe it's running more intensive applications. Virtual machine 2, I give 10 GB, and virtual machine 3, I give 6 GB. And the actual utilization of this virtual machine 1 is just 10 GB and remaining 6 GB is free. And same goes with the virtual machine 2, 6 GB and 4 GB is free, and 3 GB has been used by virtual machine 3 and another 3 GB is free. If you see the math, if you do the math, 13 GB of unused memory is blocked by virtual machines, and this memory cannot be reallocated. If I use Docker, my CPU allocates exactly the amount of memory that's required by the Docker container. So the memory is pooled for all the processes regardless of the container's allocated memory. The same example, if you have the same machine of 32 GB, if you distribute it among the containers, alright, the containers are using exactly the amount of memory which has been utilized by the processes or services run in a container. So there is no extra memory or unused memory being blocked by the containers. So which basically releases 13 GB of memory for the new containers to host applications. If you just compare side by side, there's a huge difference between the Docker and the virtual machine in terms of memory utilizations. Docker uses a dynamic memory allocation, which makes much more sense and reduces the waste of infrastructure. The piece of infrastructure is not being used when you use virtual machines. And this literally translates into a huge savings. As a Docker is using lesser memory, I could go for 24 GB RAM hardware. As RAM is a costly hardware, this saves the server cost in a magnitude of millions of dollars on a full-scale infrastructure. Scalability. As the containers are very lightweight, which means that scaling up and scaling down is really easy. We can spin up as many containers as we needed and shut down as we don't require them anymore. This is really fast, just like that. Isolation. Docker containers are as good as virtual hypervisors when it comes to isolating resources. Docker ensures each container has its own resources and that are isolated from other containers. Since each application runs on its own container, it's easy to ensure a clean application remover. If you want to remove an application, you can simply delete the container which hosts the application, and it won't leave any temporary files or traces on your host operating system. From a security standpoint, Docker ensures that the applications that are running on a container are completely separated and isolated from each other, granting you full control over the traffic flow and management. No Docker container can peek into the processes running inside another container. This architectural advantage provides you with a better management of security. For example, if one of your applications gets hacked, the services in other containers will run without any effect. The popularity of Docker is also coming from the recent surge in DevOps adoption by all the major organizations across the globe. One of the important aspects of DevOps is end-to-end automation from development to production. Ensuring consistent environments from development to production is the key to achieve this automation to work seamlessly. Docker does exactly that. Docker containers are configured to maintain all configurations and dependencies internally. As a result, you can use the same container from development to production, making sure that there is no discrepancies or any manual intervention. Also, Docker enables easy integration of different DevOps tools such as Git, Jenkins, Puppet, Ansible, etc., which otherwise would pose a huge complications. As a result, Docker has become a very important arsenal in DevOps tool chain.